This is a CNN special report.
This is a live picture from the Jet Propulsion Laboratory in Pasadena, California, where technicians take a signal that is 20 billion times weaker than the power level of a digital watch and turn it into cosmic history. And this is what the Voyager 2 spacecraft is seeing almost 3 billion miles away, an accomplishment that has impressed even the most ardent NASA scientists. The views of Neptune and its bizarre moon Triton have been called astounding. Good morning. I'm Lou Waters reporting live from Pasadena, where the work has continued throughout the night. Joining me as astronomer and member of the imaging team, Carl Sagan. That last farewell picture, that pink crescent of Triton, this last picture show should get an Academy Award.
I agree. I think it's not just great science. There's some fantastic art here, and that's part of the reason for its appeal. We are looking at the frontier of the solar system, the last planet, because Pluto's inside Neptune, and the pictures that we've seen of Neptune, of its big moon Triton, of the ring arcs are just astounding. It couldn't be better. The level of excitement is the highest I've ever seen here.
And we will see a lot of it in this next hour. It's an incredible story. And in this hour, we will spin the tale of Voyager 2. Not since 1969 and man's first footsteps on the moon has space captured the nation's imagination to this degree. Voyager's 12-year mission has rewritten the textbooks. Carl Sagan is here. It's been an astounding past 24 hours. Why don't you take us through just a bit of it?
Well, we've been in observatory phase for months, seeing Neptune as a slowly growing from a dot to something filling the television screen and more. Neptune itself, if we can take a look at some of the pictures from Neptune, is a beautiful, austere blue world. All the features you see here are in very rapid motion. We are looking at a world of clouds and gas. The surface, if any, is far below. And that dark feature you see at lower left, we call by a spiffy scientific word, it's called a great dark spot. And and the next picture will show a close-up of it. It seems to be deep. You can see the higher altitude white cirrus clouds. They're made of methane. We have no idea what's deep down there. This is a world whose the motions in it, the general circulation of its atmosphere, are important for many reasons, one of which is people trying to understand the Earth's atmosphere, climate, circulation, have a new world to test the theories on.
Is this great dark spot comparable to the great red spot on Jupiter?
It's roughly the same latitude. It has somewhat the same behavior. The great red spot on Jupiter is high. The great dark spot is low. There's a lot of things we have to figure out about that.
How about the persistence of these storms?
The great red spot of Jupiter has been seen since the 17th century. So that's a storm that's been around for hundreds of years. And the great dark spot probably is in that same category, but we don't yet know. Any
surprises for you here when you see these pictures, or was it what you expected? Which camp are you in there?
Lou, the experience of the entire 12-year mission of Voyager 1 and 2 is that we never are smart enough to predict what we're going to see. Everything is, nature is more subtle than we are. Maybe we can take a look at Triton. This moon, as you can see, has remarkable color. It's a methane ice world. The next picture shows a set of details on the surface, a wonderful flooded basin, and the next picture shows another view of topography that is different from anywhere in the solar system that we have yet to understand.
Why the intense interest in the geological history of Triton?
Well, for one thing, we've seen about 50 worlds in the solar system. This one is different from any we've seen. It's based on a different kind of physics. It's a methane ice world, and it will enhance our understanding of the entire panoply of moons in the outer solar system.
And as we continue our hour-long look at Voyager, we're going to be throwing a lot of initials at you. Hopefully, we'll always be telling you what those initials mean. You've already heard IPL, or Image Processing Lab. That's where technicians turn radio signals into something we can show you on television. And although Voyager already is streaking out of the solar system, its signal still is being translated into pictures here in Pasadena. Joining us to talk about what's going on now at IPL is CNN science editor Charles Crawford. Charles, Voyager is well past its encounter with Neptune and Triton. What's left to be done?
Well, we're at Station 9 of the Image Processing Laboratory, and with us is Ray Bambury, the supervisor. And Ray's going to explain for us a little bit about how they get these pictures from the spacecraft and also how you enhance them in color.
Well, the computers that we have here receive these signals, and what they actually receive are shades of gray. And since the spacecraft only sends back pictures in black and white, we have to convert those in color back here. And what we do is we use a display processor to convert those images. As you can see from the next series of pictures, this is what they come back like. And you can see right away that the pictures do not overlay on one another, and the particular planes are misregistered. Now, what we can do here is take these pictures and bring them out in its full color detail by subtle computations inside the computer.
They weren't together because the spacecraft's moving and the planet's rotating.
That's correct. And
now we got them all back together.
That.
Now we've got some very pretty the clouds up there and the dark spot. But what can you do for the scientists as far as even enhancing that more?
Well, as you can see, the dark spot is really not very dark in this particular frame. So one of the things that we can do is what we call a contrast enhancement, and we can bring out subtle little details. As you can see right here, the particular pictures are slowly bringing out the details that are really there.
And you can see that streamer off to the left now that you couldn't see before.
And this is the kind of thing that the computers can do for you.
Can you zoom in on it?
Oh, yes. And if you see this, I'll show you what can happen on the very top frame up here. This is the original dark spot as it was came back in color, and the particular dark spot is not so evident, but at the bottom zoom here, you'll see the actual picture come back with a very enhanced area of the dark spot.
Look at that. Why is that so important to the scientists to see it that way?
Because, as you can see, the details are just not very bright here, and if you're trying to make interpretations from this kind of data, it's just not there to be able to help you in that endeavor.
Point to some of the specific things you can see in the contrast-enhanced picture in the bottom versus the top.
Well, as you can see right here, this streamer that's out in front does not actually show very well in the natural color, but in this enhanced version, you can see the extra details which give you the ability to start looking at this over a period of time and seeing how those streamers change with time.
And again, these aren't real colors. These aren't what it really looks like on Neptune.
Well, the colors are, this one up here is about as close as you're going to get, although, of course, the exact thing, it depends upon how the display processor shows it to your eye and how your eyes interpret it.
Okay, thanks very much, Ray. We're going to come back and see some pictures of Triton later on. Back to you, Lou.
Okay, Charles, it's been 12 years since Voyager 2 left the launch pad at Cape Canaveral, Florida, and although much of what we've been seeing over the past several days has been considered the highlight of a very successful mission, other history has been made as well. Carl Sagan joins us once again. Carl, how did Voyager get from ground zero to 3 billion miles away?
I like how you say billion. It happened like this.
The solar system has been described as 4 giant planets plus debris. The debris is on the inside, little worlds of rock and metal. We live on one of those worlds, a blue one called Earth. And we've been sending spacecraft to the nearby pieces of debris. But Voyager is our first attempted detailed examination of those 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, and their rings and their moons. The 2 Voyager spacecraft are robot explorers, venturing into the outer solar system, a realm still too distant and dangerous for humans. Launched from Earth in 1977, they arrived at Jupiter in 1979 and Saturn in 1980 and 1981. The passage by each planet gravitationally accelerated the spacecraft towards the next planet, in a meticulous game of cosmic billiards. Voyager 2 then went on from Saturn to encounter Uranus in 1986 and has now arrived in the Neptune system. All in all, 100,000 pictures have been returned and a wealth of other data. Dozens of new worlds have been found and fundamental discoveries made at each of the ports of call. At Jupiter, we examined the Great Red Spot, a storm as big as a dozen Earths, and the planet's multicolored clouds, whose composition is still almost entirely unknown. Jupiter's invisible magnetic field and its deadly trapped radiation belts are the largest in the solar system. And Io, a world erupting with active volcanoes and paved with sulfur. An enormous donut of sulfur and sodium is blown out from Io and trapped in Jupiter's magnetic field. Then there's Jupiter's moon Callisto, whose surface preserves the evidence of an ancient rain of impacting worlds that destroyed whatever landforms were there before. And Europa, a world with just maybe an underground ocean. Then it was on to Saturn, where we examined the trillions of snowballs that make up its intricate ring structure, and the ring's ghostly and transient spokes. Mimas, a world so close in that Saturn fills much of its sky. The wildly tumbling, hamburger-shaped moon, Hyperion. The Voyager spacecraft scrutinized Titan, a moon with an atmosphere thicker than Earth's, in which today organic molecules are being synthesized, as happened on Earth 4 billion years ago, the steps that led to the origin of life. 5 years later, we arrived at Uranus, strangely lying on its side, perhaps due to the impact of some massive, long-gone world. And rings around Uranus as dark as soot. We gawked at Miranda, which some scientists have called the most bizarre moon in the solar system, so strangely made that it seems to speak to us of a time when worlds were shattered and reformed. And now, Voyager 2 is here at Neptune, a slam-bang finish to the grand tour.
Image processing. More about that with Carl Sagan when we come back. We are back. You are seeing pictures from the Deep Space Network here at the Jet Propulsion Laboratory in Pasadena as we get some of the latest and most dramatic pictures from the Voyager flyby of Neptune and the dramatic moon Triton. And back to the issue at hand, we're live again, and we're talking about the imaging of these pictures as they come in to the Jet Propulsion Laboratory. Carl Sagan has moved to the building adjacent to where we are. He's in the imaging area. And Carl, tell us exactly what's going on there.
Well, there is a sense of subdued excitement as a set of new pictures is coming in. These are the highest resolution, finest detailed pictures of Triton, but it's interspersed with other pictures of lower resolution. Here's Larry Soderblom, the deputy team leader. Hi, Larry. What do you see? Anything special?
Well, we're just about to see the next high-resolution view. The area we're looking at is in the vicinity of those large frozen caldera lake-like things.
Great. One of the big disputes on Triton these days is how much atmosphere is there. We should resolve this one shortly. If there's a lot of nitrogen in the atmosphere ought to be pretty dense. If it's mainly methane, it ought to be pretty diffuse. In any case, it's a very thin atmosphere by terrestrial standards. The geology has been spectacularly interesting. although the pictures that are up right now are not that apparently interesting. As I say, the good ones are interspersed with the duller ones.
Well,
Larry?
depends on what's to each his own. These are wide-angle color images.
Yes.
And so that's the color information which will be added to the high-resolution data to...
Eventually, these will be processed, as we saw with Mr. Banbury before, into very interesting color pictures, but now they are each in a single color, have not yet been composited into color. Yes?
Along the way, when the radio frequency, when we have problems with radio frequencies and you had to work with just this small amount of power, did you not go through some process where the amount of images coming back here was reduced somewhat or changed somewhat? Did that process give you less than what you would have desired as far as images back here?
Lou, one remarkable part of this mission is that the spacecraft were designed only to work out to Jupiter and Saturn. Uranus and Neptune are a kind of bonus. Because they're so far from the sun, it's comparatively very dark out there. So you have to have long time exposures, but then that blurs the image. And the spacecraft engineers have perfectly compensated for that problem by moving the cameras at just the right speed to compensate for the motion of the spacecraft. So in fact, on some levels, the spacecraft is working better at Neptune and Uranus than it did at Jupiter and Saturn.
All right. When we come back, the men and women of Voyager 2 and the human side of a robotic adventure. We're back with our live coverage of the Voyager mission with a look at what's happening just below our CNN anchor booth location. We're in the middle of the campus of the California Institute of Technology here in Pasadena, where there still is an hour or so until we'll see the first hint of dawn. As Voyager 2 speeds out of the solar system, much of the most important data of the mission is just coming in, and that's why we're up in these wee hours of the morning. The technology of this whole thing is something to behold. If Las Vegas odds makers would have had to pay off the optimists that honestly felt as though this mission would be as successful as it is, there would be a few rich people walking around NASA today. The fact is, Voyager beat the odds, incredible odds. And although in any mission of this type there must be a certain degree of luck involved, the human factor cannot be underestimated. Many of the world's journalists have broken down, packed up, and already left the Jet Propulsion site here in Pasadena, which is now getting back to normal. It was a great story left to the members of the Voyager team. This has been more than a spacecraft passing in the night. It has been a way of life. CNN correspondent Dan Blackburn takes a look at two key players on the Voyager team.
Voyager has been part of Charles Colhaze's life for the past 14 years.
Well, it began back in 1975 when I actually joined the project. It was a job I had always wanted to have, to be a mission analysis and engineering manager for a flight project. So I basically have been on Voyager for a little over 14 years. And it's been the greatest experience of my professional career. I wouldn't change a thing. If I had it to do over again, I would do exactly the same thing.
Colhaze and his team charted the flight path that would take Voyager on its grand tour of the outer solar system. They had to choose from 10,000 possible trajectories.
The launch vehicle we used, a launch vehicle called the Titan Centaur, had enough capability to have used any of perhaps 40 different launch days and many weeks of different arrival dates. That is, it could access a large set of possibilities. And the object was to try to find the best of all these configurations. And what best meant was that each of the Voyager flight paths would have the largest number of close encounters with the moons of Jupiter and Saturn. You see, the planets only line up in favorable positions around the sun every so often to do gravity assist flybys, that is where one planet sends you on to the next. Now, if you're just going from Earth to Jupiter to Saturn, those alignments happen about every 20 years. But if you want to go on to Uranus and Neptune, something, an opportunity known as the Grand Tour, that only happens once every 176 years. So when we were going through these 10,000 trajectory possibilities, we said, look, we've got to endow Voyager 2 with the ability to go on and fly the Grand Tour. I think all of the encounters return the maximum science possible, there's no doubt in my mind.
The worries of the mission design team are just about over. The spacecraft successfully entered the Neptune system and safely made its closest approach to the giant planet and its unusual moon, Triton. Now it is on toward the vast sea of interstellar space. But for other project teams, the work of poring over data and pictures has just begun. Every weekday morning, Candace Hansen, mother, drops 3-year-old Christy off at her daycare center. Minutes later, her mind is billions of miles away as she studies pictures of worlds that very few other human eyes have seen.
I'm a space photographer. I figure out where to point the cameras at what time, with what filters and what exposures.
As the experiment representative for the Voyager Imaging Science Team, Hansen has spent the last 12 years working with 20 colleagues from institutions all over the country. Hansen's job is to help decide how Voyager should take its pictures to meet specific science objectives.
Starting in December, we started taking images of Neptune. And the reason was partly just to get our exposure times right, because we don't know that much about Neptune, and especially from the ground, where it's very small in Earth-based telescopes. The most exciting moment of that time was finding our great dark spot. And we were not really sure that with our cameras, which are in the visible wavelengths of light, that we would see any contrast. And to see something that large and that similar to perhaps the great red spot on Jupiter was incredibly exciting.
Like the rest of the Voyager family, Hansen has her favorite encounter and her favorite pictures.
Discovering the volcanoes on Io and discovering that Jupiter had a ring, that was tremendous. I think that the part of the fun of encounters is knowing that we're going to be surprised. At Saturn, we didn't think we'd see any detail in the rings because we wouldn't be able to resolve individual ring particles, and we didn't even conceive that there could be the radial structure that there is or the spokes. We just didn't even imagine. Our imaginations are too small. And so what I'm looking forward to the most at Neptune is being surprised. It's like, okay, what's Neptune going to have that we never would have anticipated?
Charlie Colhays, Candy Hansen, and all the members of the Voyager team consider themselves a privileged group who have had the good fortune to be part of one of the greatest adventures of our time.
This is the Deep Space Network at the Jet Propulsion Lab. We'll be talking to the Voyager project manager, Norm Haynes, when we come back.
This is CNN, a network of Turner Broadcasting System.
This is a CNN special report.
Joining us now at our CNN Vantage Point in the Deep Space Network, Norm Haynes, the Voyager project manager. Norm has not been awake this long. I've never been awake this early. I was going to ask you if Voyager accomplished everything it set out to do, but it's even obvious to me that it's accomplished much more than that.
Well, certainly everything we thought we wanted to do at Neptune is coming true. The spacecraft's performed beautifully, and the planet and all of its satellites and rings have given us a great show.
what happened? Do you lose your job now, or?
No, actually, Voyager continues on, even though the planets are over. There are another set of instruments on the spacecraft that will continue to monitor the sun's magnetic field and the solar wind flowing out from the sun for another 20 or 30 years.
Mm-hmm. So if your job is secure, there have been, I read somewhere, 11,000 person-hours put in on this Voyager project. What happens to all the people now?
Well, we're probably going to drop down from a level of perhaps 250 people who are working on the Voyager flight team down in the next year to year and a half to perhaps 50. The remaining 200, you might ask, where are they going? There's a series of other projects at JPL.
Galileo?
Galileo, which is about to launch in October. Magellan, which launched in May, both off the space shuttle. We have more projects to launch in the coming years. So they'll move on to other things.
What's remarkable to me is Voyager with 1970s technology has accomplished what we've seen over the past 24 hours. Just remarkable. Galileo is what now? It's a step above. It's carrying 80s technology, but what degree above what we've seen now?
Well, Galileo, which is going to be launched in the 80s, is carrying technology which is only a few years past Voyager, because Galileo has been delayed several times in its launch. It started and was originally going to launch in the very early 80s, early 1982. It's been delayed for 7 years due to a variety of problems. So it's got technology which probably is a few years past Voyager's. The computers are a little smaller, they're faster, they have more memory, so it will be a more capable spacecraft, but probably not still quite up to late 1980s technology.
So you have about 5 trillion bits of information to work with now from the Voyager project?
I have to admit, I've never calculated it, but it sounds about right.
And that's going to keep some folks busy for a long time. What are we going to learn about ourselves from all of this, about Earth?
Well, I think each of the planets that we've visited is a very different world. And one of the reasons we want to visit the planets is by looking at all these different worlds, it perhaps tells us a little something more about the one we live on, Earth.
This is a once-in-a-lifetime event, and it's been a dramatic event, but I imagine you've been keeping up with certain editorials being written. One, for instance, in the New York Times, comparing unmanned space travel and what we can learn and what we can accomplish as compared to and opposed to manned space flight. Do you think there'll be a different perception within NASA, within the administration, about what we can accomplish with a robot as opposed to what we can accomplish with manned flight and the dangers, the risks involved?
Well, I think in the current administration there is a strong desire to go back to the moon, to go on to Mars, perhaps eventually with men. However, before we can do that with men, we probably need to go forward with robots to explore, to determine in detail what's there, to pave the way, if you will, much like we did back in the lunar program before Apollo. So I think from our standpoint, the two are not necessarily divergent paths. If we do want to go back to the moon and back to Mars with people, we'll have to go back before that with robotic travelers.
The reason I brought that up was it was 1972 with the shuttle approval that we almost lost this Voyager mission, did we not?
Well, there was...
Came close. Well, it was reduced.
Yeah, the original Voyager, the original Grand Tour mission, which we wanted to do, which was not called Voyager at the time, failed the first time we proposed it. It was very expensive.
Norm, thanks. Get some sleep.
Okay.
Still lots ahead on our CNN special report from Pasadena. We'll check in with CNN science editor Charles Crawford at the Image Processing Lab. We'll talk with Ed Stone, the Voyager project scientist. And we'll see what surprises Voyager may hold for unsuspecting aliens. After 5:30 in the morning on the West Coast, as we continue our live coverage of the Voyager 2 mission, we're reporting live from the campus of California Institute of Technology here in Pasadena. And you're looking at what's going on right now in the Image Processing Lab, or you're about to see what's going on in the Imaging Processing Lab. Good morning. Once again, I'm Lou Waters in the Deep Space, or at least the Deep Space Network, the nerve center of the Jet Propulsion Lab. A lot of fascinating data is coming in on Voyager. Here to make sense of it all, CNN science editor Charles Crawford. Charles.
Lou, we're back at the Image Processing Laboratory with Supervisor Ray Bambury. Ray, we've got another picture up in the monitor here. This is of, it's very, very dim, but this is Triton. What's the significance of that in terms of the light value? Is that what Triton really looks like?
Well, right when the spacecraft approached, the light there is only about 1/900th or 1/1000th of that of the light here on the Earth. And as you can see, the cameras are vastly underexposed at this time. One of the things that we can do with our image processing system is to bring out all these subtle details.
This is all new now, right?
Yes, before you couldn't see all of that there, but with this picture now we can see back in here into this area. And for example, we could look up here in that top left-hand corner where we saw the little X. Now you can see what it really looks like close up.
This even looks like a ridge. Is that a shadow back there?
Well, geologists say that it looks like it may be some kind of compressional fracture or something extruding from the surface there. And as you can see, the light comes in from the sun here, and it does appear to cast quite a good shadow.
Might you be able to tell the actually the height of that ridge then?
Yes, I think with a couple of other pictures, we can look at that in a little more detail and determine a little bit more about the altitudes.
Now, can you kind of take us on a trip across the surface of...
Yeah, well, as, starting off at the left-hand corner of the picture, we can sort of pan and zoom across the picture. This is one of the things that the display processor allows you to do, and you can start looking at the details. For example, the little mountainous type of peaks that may exist there, and sort of roam across here, get back into this dark area, or the sort of the cantaloupe skin, as people have been calling it here, and see how the detail changes across the surface of the planet. You can see some of the ridges down here. It looks like a small mountain range, perhaps.
That looks like a crater.
Yes, we hope that with some of the pictures that are coming back today, we'll actually see some of these in magnificent detail.
That's remarkable. Let's go a little bit more and see what else we can find on
if you go down
surface.
Here, we're looking down towards the bottom of the picture. We come across near the Terminator.
Another one looks like a crater.
Yes, these are going to be items that are going to be looked for very heavily. As you can see, there's sort of a very lightness associated with the Terminator, as we call it, of the planet. And you can see, as you go across here, how it varies in depth.
Okay. Ray, thanks so much for the tour. Oh, but of course, the images have gotten all the play, but there really is something more to what Voyager's been sending back besides just the pictures.
Voyager 2 is a bundle of sensors, only 2 of which are cameras. In addition to pictures, the spacecraft sends vast streams of data back to Earth, measurements of all kinds of particles and radiation. Voyager's scan platform, for example, aims an infrared detector at moons and planets, taking temperature readings like an interplanetary thermometer. Some instruments measure complex radiation fields, while others answer questions about the sun and solar wind. One of Voyager's most powerful scientific instruments is its radio transmitter. Investigators on Earth learn about the atmosphere of Neptune and Triton by studying how the signal changes as the spacecraft travels behind those bodies. The plasma wave detector returns data that scientists on earlier encounters have turned into something like cosmic music. Sophisticated computers at the Jet Propulsion Laboratory turn the numbers streaming down from Voyager into colorful displays. Scientists say the visual representations are an efficient way to understand immense quantities of complicated data. This image shows the impact of dust particles, showing up as plasma wave signals as Voyager passes through the Neptune ring plane. Voyager's instruments have already told scientists a great deal about Neptune and its moons, about the planet's magnetic field and atmosphere, and about its rings. Revelations that follow in the best tradition of earlier flybys, a fitting finale to the grand tour.
Joining me here at the CNN anchor booth is the Voyager project scientist, Dr. Ed Stone. Elaborate, flesh out somewhat these 11 investigations beside the pictures that were part of the Voyager project.
Well, we have really a very comprehensive set of scientific investigations, because if you really want to understand the planet and its moons and its magnetic environment, you have to do more than just take images, although the images are obviously very important. For instance, if you want to learn how long a day is on these giant planets, since there's no solid surface to image, we have to actually measure the magnetic field, because the magnetic field is generated deep inside the planet, and the rotation rate of the magnetic field is the only way that we can actually learn how long the day is on these giant planets.
All these antennas and doodads sticking out, that's part of that project. And have all of these functioned well through this shot through space?
Yes, we're still waiting for some of the key data to be played back from the tape, but we did sense the bow shock, which tells us that, in fact, we were approaching the planetary magnetic field. We are now, in fact, we have passed through the planetary magnetic field, and we have the key data, which tells us how strong the field is and what its rate of rotation is on tape being played back over the next day or so.
And that will be employed in the process of determining when Voyager breaks out of the sun's gravity into the heliopause, is it?
Oh, that's going to be some time off yet. But we will be able to first of all, break outside of the planetary magnetic field back into the solar magnetic field very shortly. Now, another thing that the instruments tell us, for instance, one of the key questions is what kind of an atmosphere does the moon Triton have? This wonderful moon that we've discovered, the surface, what the surface really looks like. It could be methane, that is natural gas. There could be nitrogen there. There could even possibly be carbon monoxide. It's the other instruments which, in fact, will tell us that. The radio science will actually allow us to observe the deflection of the radio beam as we pass behind the moon. We'll watch the sunset as we go behind the moon. Those are two key observations which will tell us what that atmosphere is like.
Dr. Ed Stone, our time has slipped away as Voyager slips away. We're going to take a break, and we'll be back with more coverage of Voyager 2. We are back with our special coverage of the Voyager 2 mission. What are we looking at, Carl?
It's people in the imaging area seeing some new pictures and newly processed pictures coming down. And what they are looking at is the ice plains of Triton, which are covered with patchy, reddish, dark blotches, which seem to be organic molecules. The same processes in Triton today that were the early steps 4 billion years ago in the Earth for the origin of life. Nobody thinks there's life there, it's too cold, there's no liquid water. But organic molecules almost certainly are being produced abundantly on Triton. One of the many reasons why it's fun to find out what's happening there.
Spend a little time on the romantic side of the mission, which I would regard this as a great part of, and that's the Sounds of the Earth record that's on the spacecraft. You played a part in it. Tell us about it.
Well, there's a nice piece that we're going to go to on it, which describes it. But
we can do that.
But
let's go to it.
Okay, this is the record, and let's see how it came about.
As each of the two Voyagers left Earth for the planets and the stars, it took with it this message, a phonograph record encased in a golden mirrored jacket. The record contains greetings in 59 human languages.
Hello from the children of planet
and one
Earth.
whale language. A 12-minute sound essay of the evolution of life on Earth. 118 pictures and 90 minutes of music. The Earth's greatest hits, East and West, classical and folk, including a Navajo night chant, a Pygmy Girl's initiation song, a Japanese shakuhachi piece, Bach, Beethoven, and Chuck Berry singing Johnny Be Good. Space is so empty that there's virtually no chance that Voyager will ever enter another solar system, even if every star in the sky is accompanied by planets. The instructions on the record jacket, written in scientific hieroglyphics, can be read and the contents of the record understood only if alien beings, sometime in the remote future, find Voyager in the depths of interstellar space.
And I'll have to ask you, of course, because I love to hear you talk about this subject, would you expect someone to find this record out there? Is there something out there?
Well, nobody knows. One of the great unsolved questions is whether we're alone or whether At the opposite extreme, the galaxy is full of civilizations, many of them more advanced than we are. Nobody knows, but it's a kind of arrogance, it seems to me, to suppose that of hundreds of billions of stars, ours is the only one which has an inhabited planet. I'd be think it much more likely that the universe is burgeoning, overflowing with intelligent life, and if that's the case, maybe there'll be someone to pick this up in interstellar space.
Okay. A final check of Voyager's status and a final word from Dr. Sagan when our CNN special report continues. A shot of the Deep Space Network, restricted ops. We won't go in there. As we continue our coverage of the Voyager 2 mission, in a sense, we've come full circle. Our mechanical Christopher Columbus is headed out into uncharted waters. This could be the last time we hear from Voyager, but it has left quite a legacy behind. Carl, what's the historical significance of it all?
Well, one way to look at it is that here's this solar system which we, for the longest time, only knew about one planet, the one we live on, the Earth. And then gradually we began exploring nearby worlds, only in the last 30 years. And now, today, the Voyager 2 spacecraft has reached the furthest known planet, because Pluto is inside Neptune. So we are in the process of having completed the preliminary reconnaissance of the solar system. It's a fantastic historical achievement. There's only one generation privileged to be alive when that happens, and that's our generation. And those few scientists like me who've been lucky enough to be personally involved with it, there's a feeling of significance that's very hard to put into words. So now we're going to do more detailed studies of the more interesting worlds. We, as both President Gorbachev and President Bush have called for, there will be human exploration of Mars and eventually other worlds. There will be a time when people will be on some of the worlds that Voyager has examined, and they will look back to this time as the first moment when we found out what those worlds truly were. I think this mission will be in the history books for thousands of years.
What's next? Galileo is next. We'll start a new process of discovery.
It's true. There's a lot of interesting missions in the pipeline. Since the Challenger disaster, a lot of them have been held up, and now the pipeline is flowing again. So Magellan is on its way to Venus to, with radar, map the surface that's hidden by clouds. Galileo will be launched in October to study Jupiter. There's a mission called Craft Cassini, one part of which is to land on Titan, a moon with organic matter falling from the skies like manna from heaven, which I hope Congress will see fit to pass. But the big picture is to tool up for Mars. Both the Soviets and the United States are doing that. I hope we will manage to do it cooperatively. That'll save money, and it'll also enlarge the constituency of people who support this kind of exploration. I think there'd be nothing more fitting than the two contentious superpowers working together on a grand, stirring, historic, long-term, high-technology endeavor. I think there's a great deal to look forward to.
I was talking to Norm Haynes about the detractors of manned missions in light of Challenger, as you mentioned, and the success of this mission. What would you tell those who would shoot down the effort to get man up there on Mars and on the moon, first of all?
And woman.
And woman. I was speaking.
You see, I think there's some merit to that position. If we're only interested in finding out in science and exploration, send robots. And if they're not smart enough, send smarter robots. They're cheaper. You don't sacrifice human life. You can go to more dangerous places. The reason for sending people has to be more than that. It has to be something political or historic. And the Apollo program was an example of that. That was competition with the Soviets in the context of the Cold War. Well, that time has passed. This is the time, I think people all over the world are crying out for it, for cooperation. And the idea of the two nations working together on something of this significance, I believe, provides that additional political and historical justification which makes sending people reasonable, makes sense, broadens the constituency of NASA and their Soviet counterparts. I think that's the reason for sending people.
Do you think the administration, NASA, and the American people are getting together on a project? Is there the proper vision there?
The
yet?
American people, as is often the case, are ahead of the administration. I think the administration is coming along. Recent opinion polls show that 71% of the American people want to explore Mars with humans, with the Soviets, and if it's done just by the United States, something like 30% are for it. The key is cooperation, I believe.
Carl Sagan, it's been a wonderful story. Thank you very much.
Fun to be with you, Lou.
So we've come to the end of our galactic journey, but there will be much more to tell. Maybe it's best told in a Jet Propulsion Laboratory publication. It reads, as Galileo could never have guessed how his discoveries would benefit mankind, neither can we fathom what impact the Voyager discoveries will have during the coming centuries. Our satisfaction comes from knowing that we were given a rare opportunity and that we seized it. For Carl Sagan, I'm Lou Waters. That's our special report on Voyager 2, the final encounter. Have a good day.
This has been a CNN special report.